All right. Thank you so much for joining me today, especially on this almost fall break eve. I appreciate you joining me this afternoon. My name is Molly Webb. I am a Geographic Information Systems or GIS and data developer with the data services team at Washington University Libraries. I'm also a GIS instructor at formerly University College, currently CAPS or the School of Continuing and Professional Education. I'm here with you today to share some tips and considerations when you're working on visualizing your data. I stopped short of calling this presentation best practices because sometimes data visualization is subjective, and I have much of my own point of view in this presentation. But there are some generally accepted and common sense things in here. So I hope that you'll find at least parts of this useful to your own work. Also, while the use and display of three-dimensional or 3D data and graphics is becoming more accessible to the average user, this presentation is going to focus on two-dimensional or 2D visualization. All right, so let's get started by discussing some things to keep in mind when it comes to visualizing your data. And the first is, of course, the data. So data visualization is communicating with visual models of your data to make it consumable. You ideally want to be able to tell the same story to both experts and non-experts, even though the specifics of how you tell that story might vary. But either way, it is all about the data. Visualizing your data doesn't have to wait till the end of your project either. So creating visualizations at different stages of the research process can provide insights. It can help you explore the variability of your data or discover relationships between variables that you wouldn't otherwise be able to see if you were just looking at a table, for example. When it comes to communicating your findings at the end, more isn't necessarily more in this case. It's really important to choose the visualizations that are key to the story that you want to tell. Creating visualizations typically involves some kind of specific preparations on your data as well. So we did talk about data wrangling during the workshop from this series a couple of days ago. If you're interested in hearing more about data wrangling, that video is also up on the Data Services YouTube channel. So you may have gathered and prepared your data for analysis, but the data may need to be reformatted or enhanced in order to visualize it properly. So this is commonly called data wrangling, like I mentioned, cleaning, scrubbing, normalizing. The output is typically a new table or maybe multiple tables and or reformatting existing tabular data. Keep in mind that you may need additional information to normalize your existing data so that it can be easily compared across categories. So an example of this is normalizing COVID cases per 100,000 people to account for the differences in county populations for the areas being compared. If you look at total counts like this map on the left, you may think that certain areas are much worse than they actually are, since logic tells us that areas with higher populations are going to have a higher number of cases by default. But by normalizing the data using a rate, like this map on the right, it makes the comparison across different areas more accurate and easier to tell where the hot spots or the worse off areas are. Another consideration when creating your data visualizations is the planned audience, or at least have an idea of the audience you're working towards. It's important to consider both what you want to focus on as well as what the audience might want to see. So, are they administrators of your organization? If your audience is a group of decision makers or funders, then be sure to tailor information to their requirements or items that might be relevant to their evaluation. Information presented should be compatible with the specific expertise of the audience. If you are presenting to a group of peers, for example, you could probably take more liberties using jargon or acronyms, but also take care to make definitions accessible to those that might not be as steeped in your field, such as students. So say you're presenting at a conference, some folks might be able to tell what acronyms are, but there might be some students or less experienced people in the audience that might need a little bit more definition. If creating visualizations for the general community, I recommend keeping things as simple as possible and use really bold yet cohesive and meaningful colors to highlight the key takeaways at a glance. So the bottom line is that you never want your audience to have to work too hard to interpret the meaning of your visualizations. The audience may also determine which platform or medium you're going to use. So the final display or consumption platform or medium of your data visualization is also important to consider. So are you presenting in person? Okay, well, make sure your viz has sufficient size and contrast to account for things like bright lights in the room or a weak projector. Is your audience particularly tech savvy? Then you might want to consider making your visualization interactive or at least having it in some kind of digital format. But then some audiences may appreciate a printed handout instead of clicking on a link. So just keep these things in mind. And also, with this in mind, you might need to consider making different versions of your visualization tailored to a particular platform. Also related to the medium, if you're creating visualizations for publication, be sure to check the specifications of the publisher, preferably before you start creating those final versions. Shown here are some excerpts from the formatting guide from the journal Nature, as well as their standalone guide to preparing the final artwork to be inserted into the publication. So make sure you locate this or reach out to the organization, read and understand this ahead of time so that you're not scrambling last minute to make changes to your visualizations. Publications also might have guidelines in terms of whether or not figures can be in color or black and white. So that's also something that's really important to know getting started. Speaking of color, color is the first consideration in this basic list of visualization principles we're going to go through. So color can be one of the most important ways of separating data points into groups or series or indicating difference. It's important, however, that the color be used to simplify the data and not confuse it. Use the color to signify meaning when appropriate, and don't use it when it doesn't have meaning. And here's what I mean by that. So take a look at this bar graph here in the upper left. The data is already grouped into categories or separated by the categories by the bars. So making the bars different colors doesn't help to differentiate and actually might cause the audience to search for meaning in the colors when there really is none. So if color doesn't mean something, then make it a consistent color across the entire graphic. Same with maps. So consider this map of Missouri counties in the middle. The top map shows each county with a different color, which is unnecessary unless these colors actually have some kind of meaning. If the colors don't mean anything, then it's best to use a neutral color or consistent color like the gray in the bottom middle. The donut chart here in the upper right shows the category with the largest proportion of the whole in a light color right here. Now, our eyes tend to fill in areas and patterns on our own. So generally in this kind of situation, you'd want to use something similar to the bottom pie chart or donut chart where the darker color is the main color and then the lighter color is used to kind of fill in that space. So when color does matter in your visualization, it's important to choose those colors wisely. So there's many considerations when you're choosing colors, but here are some suggestions when it comes to the nature of your data. So these color palettes here, I've sourced them from Color Brewer, which is a great website to help you with your color choices. The site itself is geared towards cartography, but the suggested palettes work for non-spatial data as well. There's lots of different color palette generators out there, so a quick Google could probably bring you up lots of options if you want some color inspiration to go beyond those default color choices that our applications tend to throw at us when we're creating visualizations. So starting at the top, a diverging color scheme gives emphasis to both the low and the high extremes of your data, but it also makes these middle values easy to recognize. So it's best for situations where there is kind of a mid-range critical value shown in the data, like the mean or the median or maybe zero. This scheme shows which data points are above and below that important mid-range value, using different hues to easily interpret those highs and those lows. When the numeric value of your data matters most from lowest to highest, consider using a sequential color ramp like this, where you have one general hue and where lighter versions of it represent lower values, and then the ramp progresses towards higher values with the darker versions of the color. And then if you don't want colors to represent a particular magnitude, but a difference between the categories, consider a qualitative color ramp or color scheme where different hues are used to create that visual separation. All right, so kind of related to color is contrast, or the difference between the color choices of the elements in your visualization. So like I mentioned before, the platform that you're using is a big determinant for how much color, for how much contrast you should use with the colors. Again, this is especially true for in-person presentations in front of a group, or nowadays we're still doing a lot of presentations on Zoom. So you might not have control over the lighting in the room or the resolution of the projector or screen. So it's important to make sure that all of the elements have sufficient contrast so they can be seen and interpreted at any distance away from that screen. Contrast can also help viewers who may experience different variations of color blindness and other visual accessibility needs. So they can still gain they can still kind of get the gist of your visualization and the ideas that you're trying to convey, even though they might not be able to interpret the exact colors that you're using. So for example, take a look at the graphics here on the top row of this slide. You might not even be able to see them. They're there, but the color is so similar to the background color that they're almost invisible on most platforms. So a better bet would be something along the lines of the bottom row of graphics here, which use a highly contrasting color such as white, so graphics stand out against the background. If you do, again, a quick Google can bring you to lots of different contrast calculators that can even take in an image and let you know if that image is of high contrast enough, and then you can make adjustments. So another great tool to use is kind of a contrast evaluator. If you're tied to a particular color, maybe because of branding guidelines or something like that, try maybe incorporating an outline or a stroke to the graphics to distinguish them from the background color. The same principles apply to text. So the gray text in this top bar here would probably be almost invisible on certain screens or on a projector. So when selecting the color for text, it's best to stay simple with a dark gray or a black, unless you want the color, again, to convey some kind of meaning. Along these same lines, black, like straight up black text on a white background can be a little harsh on the eyes. So my preference is to use a dark gray here. But when you do use a dark gray, keep in mind that you may want to make sure that all of your lines and symbols are in, such as the tick marks or axis lines or whatever, that would typically be black by default. Take some time to make sure that you have changed those symbols as well. This is going to make for a more polished look when you have kind of consistent line work across all of your graphics instead of a combination of the dark gray with the black. So color and contrast do go hand in hand, usually. Too many colors in a visualization can overwhelm the viewer, and there may not be enough contrast between the different colors to adequately interpret the different categories. So the map on the left here represents 10 different classes of data, which is probably too many. It would be pretty tough for the viewer to distinguish, especially between kind of these lighter greens and then we're getting into the blues. It's hard to tell exactly which one is which on the map. So as a rule of thumb, it's preferable to keep the colors in your visualizations to about 5 or less, unless there is some kind of extenuating circumstances, like you have more than 5 categories to show, or you have to get everything on one graphic. 5 is about the maximum number that the human brain can really distinguish comfortably. And remember, it's all about making the viewer not have to work too hard to interpret the meaning of your visualization. All right, next up, we're going to talk a little bit about balance. So, when we're creating visualizations and especially grouping them together, we want to do our best to keep that presentation space in balance. So, this doesn't necessarily mean that the two sides have to mirror each other, but that the elements are kind of equally distributed across the full presentation space. This is especially the case when working with media where you plan to present multiple visualization elements like a dashboard or maybe a poster. When it comes to including these visualizations in your work, again, you don't have to necessarily put everything in one place. It's important to choose the visualizations that are key to that story that you want to tell. So, I like to think about balance within the framework of a couple of different types. So we have symmetrical, where essentially each side mirrors each other, like this top and bottom. Symmetry tends to give kind of like a classic traditional look. There's the asymmetrical framework, where all the unique elements, where all of the sides have unique elements, but all of the sections carry kind of a similar visual weight. This layout is sometimes considered a little bit more relaxed, but it still can be in balance. Another example here is this radial presentation, which focuses on a central element and then has other visual objects filling in the space around. So this layout is obviously going to bring the attention to that central focal point. Also, in terms of balance, be sure to take advantage of any arrangement or alignment tools or guides within the application that you're using to create your visualization. So this includes tools that might let you align things to each other, distribute them evenly across your space, and maybe make all the elements the same size. Often that is an option in your alignment tools. And a quick Google can tell you where these tools might be in your preferred application that you're using. But aligning and distributing the elements in your space will help with the balance, of course, but it will also make your entire presentation look more polished and more professional. Next up, we're going to talk about legibility. So basically, can your viewer read and see clearly the information in the space? Can the words and letters be distinguished from each other? Can the graphics be interpreted and the objects within be identified? So take a look at these two logos here. If you're designing something for a large format like a poster, Be sure to obtain the high resolution images or logo files for whatever you might be wanting to show to avoid pixelation like this logo at the top is. I've printed a lot of posters here at the library and I see a lot of pixelated logos. So don't just grab images off the internet or take screenshots. Try to reach out to the originating creator of the image or the logo to get a high resolution file and then use that in your large format presentation. Also, kind of related to posters, avoid small text or large blocks of small text if your presentation is meant to be viewed from afar or a little bit farther away. Um, Here's an example that we're seeing right now. Or if you have a poster session or something, you know that people are going to be standing kind of far back from your poster. They probably won't be able to read this small block of text like this. So instead, I would suggest to just put a brief description in your next to your data graphic, and then perhaps provide an additional link or maybe a handout if you want to provide more information about the phenomenon that you're displaying. In terms of legibility with fonts, it might be kind of tempting to spruce up your visualization with like a cool font, but try to keep the fonts as classic and simple as possible. So this graphic on the left here uses Comic Sans, which gives kind of like a casual vibe to your visualization. And it's kind of a controversial font among graphic designers and typographers. There's definitely more professional options out there, even if you are going for a unique look. The font in the middle has serifs, which are the little small strokes at the end of some of the characters. And depending on the situation, serifs can sometimes make it difficult to distinguish the characters from each other. So, best to kind of avoid those and also avoid other decorations such as drop shadows. It can make the characters kind of run together. So there's no kind of one size fits all font, but typically I recommend going with a clean sans serif font like Arial or Helvetica, like this graphic here on the right. And while we're on the topic of fonts, um, definitely avoid using the vertical orientation for characters like this y-axis right here. When trying to fit in a piece of text into a small vertical area, just rotate the characters so that the bottom of the label is aligned with the graphic that it's describing, like this graphic here on the right. And then finally, transparency. Um, and so by transparency, I mean being clear about the source and the intention of your data, not transparency like see-through. So it's important that your visualization doesn't misrepresent your data, even though obviously we do want to tell the story that we intend. So, don't use tricks like uneven intervals between numbers or classes or inaccurate or inconsistent scales when doing comparisons, or I've even seen fudging with the starting point of an axis to exaggerate the values. A couple of examples of this here. So this bar chart on the right, um, it's probably intending to highlight the decrease in the percent increase over the time periods, but none of these scales make sense. The bars aren't really proportional to any of the values being shown. So just, I'm sure that it's not intentional, but we are kind of left wondering what it is we're even trying to see here in this visualization. There's several issues with this graphic here on the right. Again, I'm sure it's not malicious, but it is kind of deceiving. So one of the things we're seeing in this graphic on the right is that we're talking about an inverse scale here. So this graph is asking which method of transportation should be a priority in this neighborhood, one being the most and six being the least. But then in the graphic here, it's being shown from 1 to 6. And so really you would expect that to be kind of flipped. Here's an example of the colors of these bars not really meaning anything. They're already separated out into the bars. So do we really need color here? I would say no. And then also, despite the fact that each category is labeled underneath each bar, the data creator did also include this legend here, which is just replicating the things that we're seeing just above it. And so the legend here, I would argue, is completely unnecessary. In terms of transparency, if you did not collect the data yourself, then obviously you have to reference the data source. And if the data source is publicly available, then definitely provide a link or some kind of citation. Descriptions of the data should be clear about the methodology that you use to prepare and analyze the data and the source and the limitations of this data. It's important for the viewers to understand that this visualization is kind of like your curated view of your data, and there's probably other things that are not included. So just be clear about these items here, either as a caption or in the body of your report or whatever. Be clear about these items. So just wrapping up this section, seriously, each of these principles that we're seeing here could be studied and discussed at length, probably for many, many hours. But my point in including them here in this presentation is to just ask you to make conscious and deliberate decisions when it comes to the visualization of your data within the framework of these principles here. We're going to move on to some types and tips for different types of visualizations. So since you're sitting here in this presentation, you probably know that the number of types of data visualizations are growing all the time. I feel like every day I see new types. And it's really easy to get overwhelmed with all the different options that you have, and we're just bombarded with data viz on a daily basis usually. My recommendation is always to keep it simple and focus on the main objective or the result of your research in making these choices. So something that you might want to consider is using like a chart chooser like this. This was created by Andrew Abella, and you can access it at extremepresentation.com. It starts with the simple question, what do you want to show? So do you want to show a trend over time and you have many time periods worth of data that's non-cyclical? Okay, well then maybe choose a line chart. Do you want to show the relationship between two variables, but you also want to show magnitude? Then maybe consider showing a bubble chart where the sizes also convey meaning. The sizes of the points also convey meaning. So lots of different options here. Again, I'll be sending out this presentation so you can have that, or you can go to extremepresentation.com to see the original version. So charts and graphs are very similar, and charts and graphs are also often used kind of interchangeably. They both rely on an established pattern or theme to convey information. Some experts consider the difference between these two to be that graphs rely on an axis, like an X or a Y axis, or maybe both, to make sense of the information. So that means that at least in graphs, at least one of the data points is going to be numeric. When you are creating a chart or graph, like I mentioned before, avoid the impulse to add more information or graphics or decorations. Some experts even recommend using things like tick marks like these along the axes of your graphs. But the important thing is just to be consistent. Make sure that the spacing and the intervals along your axes are consistent. If you're going to use proportional symbols, make sure that the size of the symbol is in fact proportional to the value that it's representing. If you have two data points that would require different scales on the same line or bar graph, like this example here, um, I would recommend against doing something like this. Instead, consider splitting them into two separate graphs and maybe showing them side by side. While not set in stone, if you, like our chart chooser said, if you have relatively few data points, consider using a bar graph like this 15-month bar graph here on the left. If you have many data points, then consider using a line graph so it's easier for the viewers to recognize a trend. When showing data over time, a line graph is often better than the bar chart because the line will show the trends more clearly. So here's an example of a graphic that doesn't necessarily follow this guideline, but it still works to convey the data. It's a graphic showing both bars with the daily cases of COVID in the US, as well as a line showing the 7-day moving average. And this example works because the data is at the same interval and scale. So it makes sense to see them side by side, or excuse me, on top of the same graph. Also, speaking of scale, here is an example where the two data points are bars and lines, and technically they're the same interval and scale, but I would argue that this is a little bit less of a successful visualization just because of the magnitude of the values. So we're seeing cases and deaths shown on the same graph, but the value of the deaths data point is so much farther below the cases that we can barely see what's happening with the value of the total deaths data point. So for this, this would be a place where I would recommend maybe having two separate graphics. So when we're talking about bar graphs, pay attention to the order in which you place the bars. So this graphic on the left shows data in alphabetical order by category A, B, C, D, E. And so this isn't wrong, but if the point of what you're trying to do is show the which category is highest, which is lowest, then consider reordering so that the category with the highest value is at the top. You can easily see which one is at the top, and then all the other ones follow down below. And so this works in cases like this, but if you have something like this where you have a time-based metric or category, then that of course forces the order of those bars. So here we have Q2 20, Q1 2021, Q1 20, all of these bars, we've ordered them in terms of highest to lowest, but the time order is incorrect. So for a time-based graphic like this, you would want to make sure that you adhere to the time order so it's easy to see the trend between the different quarters. All right, so this would be a case where we would need to stick with that time order. All right, so next up is pie charts, okay? Very controversial. I know that pie charts and donut charts have kind of a mixed reception among data scientists and design experts. I personally feel like there's a time and a place. All right. If you do choose a pie chart, make sure that you're using it appropriately and they are representing proportions of a whole and that your percentages add up to 100. If you're trying to show something like a percent change or a percent increase in growth, then chances are a bar graph would probably be more appropriate as opposed to a pie chart. So it's recommended to order your portions in from largest to smallest, starting at the 12 o'clock position and kind of wrapping around clockwise. Also, try not to include too many slivers or pieces of the pie. If your visualization gets to the point where you have more than or one or two callouts showing sections that can't be labeled directly on the piece of the pie, then you may want to consider combining categories into an other section or maybe separating out the data points into multiple pie charts. So, a couple of examples here. First of all, on the left, if you're going to use a pie chart again, make sure that the slices of the pie actually match the values. So here, this yellow portion is clearly not 72% of the total. All right. Oops. There we go. So just make sure that the values match the size of your slices. On the right here, we have a situation where we have multiple call outs. So again, this is probably a few too many. And then we're having another situation here where we have kind of a legend showing things that are also labeled. And so again, I would argue that this legend right here is unnecessary. Finally, for this example, we have somehow made this pie chart 3D. And my only question for this is why? Why do we need a 3D pie chart there? I would argue that we don't. Okay, so moving on to maps. And of course, I'm a GIS person, so I have to at least give maps a passing mention here. So maps are just another way of showing data by categories or groupings, but also by geography or place. These two examples here show us two of the different color schemes that we discussed earlier, the sequential that is showing us the values from low to high using the same hue. And then we also have an example of that diverging color ramp where it shows us values that are both above and below a mid-range value. We can see here that the little change category is marked in kind of this neutral yellow category or color, excuse me. So using maps can be a really powerful way to visualize a data that is tied to a specific place on Earth. So for example, if you come in and you have a table, maybe similar to this, where we have some age data represented by zip code, we've got the age, it shows us the number of people 65 and older for that zip code, and then the percentage of the population that is 65 and older. So same with any tabular data, it's kind of hard to see what's happening when you're just looking at a big table of numbers. But since each one of these records is tied to a specific area or zip code, we can translate that to show this data on a map. The map can help us make sense of the data, and it could also maybe help direct further action. So, for example, if we know the areas with a higher percentage of people over the age of 65, then perhaps we can target specific services for that area. And creating a map doesn't have to be a daunting task either, and you might not even need a specific mapping application. There's lots of web-based tools that can help you create maps, and anymore, there's plugins for Excel that can help you create maps right within Excel. So if you do have data that is spatial in nature, consider making a map out of it. All right, so the next thing I wanted to show you was interactive. And so I'm just going to pop out of the presentation to show you this visualization actually here in an application called Tableau. So depending on the platform or goal of your visualization, you might want to consider creating something like this, an interactive graphic. And this lets users explore the information by clicking or hovering. Maps and dashboards, kind of like this one, allow your user to really kind of dive deeper into the information more than what you can see at a glance. And it also kind of forces the reader to spend a little bit more time looking at your visualization. So despite this extra layer of complexity, though, the same principles apply. You still want to keep things simple. Don't try to do too much with a single visualization. And just make sure that all of those same principles apply, even if we do add some interactivity to our viz. All right. So, um, I love this little quote by Edward Tufte here. So basically, we know that there's a lot of considerations that we need to think about when we're choosing which visualization to use. And again, I just want to say that these are kind of my preferences, my tips that I see researchers struggling with a lot in my work here at the libraries. There's lots of different other types of visualizations and principles that we didn't cover here. But I did provide a resource list at the end of this presentation, which I'll send out, that will give you more things to explore if you're interested in diving in further. So the bottom line is to keep it clear, simple, focus on the data, and then like this quote here, data graphics should draw the viewer's attention to the sense and substance of the data and not to something else. All right, I'm going to go through just a few tools that are kind of in my toolbox that I like to use. And so should you have any questions about these tools, feel free to reach out. So when you're wanting to do static visualizations, of course, there's Microsoft Excel. That's one that everybody is familiar with. There's the R programming language with the IDE R Studio, which can make some really nice visualizations right within the application. Of course, there's Adobe Illustrator and InDesign. If you are comfortable with scripting, Python has lots of different viz libraries, one of which is Plotly, which is pretty easy to use. If you're interested in doing mapping in a desktop environment, the two recommendations I would have for you there would be an application called ArcGIS Pro, which you can get a license for through the library. You can let me know if you have any questions about that. And then also QGIS, which is an open source cross-platform mapping application that you could download to your machine right now if you wanted to. You just go to qgis.org and there you go. In terms of interactive mapping, there's ArcGIS Online or Story Maps, which are really growing in popularity these days. There's also a platform called Mapbox. Social Explorer allows you to create maps within their platform. And then again, for those of you that might be comfortable with coding, there is a JavaScript library called Leaflet, which makes it really easy to create web-based maps. In terms of interactive visualizations, there's Tableau, which was the application that I showed you a couple of minutes ago. Similarly, there's an application called Microsoft Power BI that is very similar to Tableau. And then also there's an application called Spotfire, which has a lot of the same functionality. If you are interested in getting to know Tableau a little bit better, there is a Tableau users group here on campus. And so there's a link to their website if you want to sign up for their mailing list. All right. So in these last few minutes we're going to kind of play a little game. We're going to do a data viz critique. So what I'm going to do is I'm going to put a viz up on the screen and I'd like you to take a look at it and maybe put in the chat or feel free to unmute and just tell me some observations or things that you think could be improved about this particular visualization. And we'll start with this one right here. So I'll go ahead, I'll let you look at that for a few minutes and feel free to put any comments in the chat. What do you think about this viz? What are some areas of improvement? Anybody care to comment? Okay, so we have a comment here. The background image makes it a nightmare to try to see the line. Absolutely. Really tough to tell even what's happening in this viz with that atrocious background. Any other things that you notice about this viz?
The x-axis scale has irregular intervals. Some are 1 year, I think some are 4, and others are 3 and 2.
Absolutely. You're right on. Definitely inconsistent intervals. Yeah, the having so much red on the background image and then those labels in red is also really hard to see. The labels for each of these data points here are in practically the same color as the image. So we're having a contrast issue there for sure. The image is blurry. Absolutely. This background image is not a high quality image. Even, I mean, it shouldn't be there in the first place, but even though it is, it's, distracting because it's a blurry image. Any other thoughts on this one? Thank you for those observations. Those are actually exactly what I was thinking too. So we've got that unnecessary image there, the inconsistent x-axis, and then I missed getting this one on the slide, but I do really appreciate the call out for these labels here. It's really hard to see these values, especially this one. This one kind of blends right in. Yep, interval between years, absolutely. All right, let's try another one. Go ahead and take a look at this. Let me know what you think. Any observations about this pie chart? Guess we could call this a pie chart or some kind of radial diagram.
I don't think the title is very clear. Um, I don't know. I can't really tell what it is. Maybe like a government budget allocation, something.
That is my interpretation, but also, yes, it's hard to say what they're even trying to convey here with the viz. Yes, the comment, at least it adds up to 100. Okay, well, we'll give them that. All right, we'll give them that. Um, yeah, absolutely. So the big one for me, as Brian put in the chat, the slices are not the size that they should be. And I'll just go ahead and go to the things that I wanted to point out. So the pie pieces are not proportional to their value. I would also add that these icons right here are kind of unnecessary. They add clutter to the viz and I feel like aren't really helping convey the meaning very well. Also, another thing that I kind of alluded to, but not really, is this text rotation right here. So, um, you know, they do kind of a mishmash job of their text rotation. So I can see that they're wanting to follow the shape itself. But these two, they go ahead and they full on flip so that they're easy to read. But then this one here, you kind of have to like crane your neck a little bit to read exactly what it says. So the text rotation on this piece kind of stuck out to me. I wasn't really super crazy about that. Anything else about this viz that stands out for anyone? All right, we're going to do one more. All right. And this one, of course, it's a map. So what do you think about this map? Okay, yeah, New England is cramped. Definitely those labels are kind of crammed in there and aren't, well, I guess they're kind of over the states that they represent, but yeah, there's not a whole lot of wiggle room up there.
I think that the metric is a bit misleading because the number of positive wild bird samples, I don't know, maybe some states have more birds than others. I don't know how you could even do a proportion out of that, but I don't know if the raw numbers are really getting at severity. I don't know. And also maybe colors would have been better.
Yeah, both of those things, absolutely. I 100% agree. I'm not exactly sure how we would normalize these. But setting that aside, yes, if you're going to use a map, then what's the point of just dropping the labels here? Why not just give me a table? In the chat, we also had wait, where's Hawaii? Absolutely. What? It's not here. Could have added shades of a single color. Absolutely. Maybe use kind of a sequential color ramp to convey these values. I think you all hit the points that I had, with the exception of one that's a little nitpicky for me. But obviously, why not indicate values with color, either alone or with the labels? So again, kind of a missed opportunity with this map, I think. Again, yes, where's Hawaii? It's not on this map. If you're going to omit data like this, then, just say data for Hawaii not collected, or no data for Hawaii, or, acknowledge it in some way. And then also, I would argue here, so the scale bar here is for 900 miles. This is a little bit nitpicky, but 900 miles isn't really, a number that we can internalize very well. So, why not use like 500 miles or 1,000 miles, or, something that's a little bit rounder, nicer? When, I know probably how this map was made, and it would be a really easy fix just to kind of make it a little bit more concise. Question in the chat: this is an official USDA map. Absolutely it is. I pulled this right from the USDA website. And another thing I would argue is that, this little patch here says states with HPAI detections in wild birds. This is unnecessary to include this little patch right here, because they're all the same. We don't need to include a legend if the colors are not really signifying anything. All right. Well, thank you for playing my data viz critique game. I really appreciate that. As I mentioned before, I'm not going to go through these, but I do have several links for resources for you to check out. I do have a couple of tool demos recorded here if you'd like to check those out for Excel, ArcGIS Pro, and Tableau. And finally, I would just ask you to jot down the website of my team, Data Services, as you go about your research and your work here at WashU. Please do keep us in mind, not only for data visualization and mapping, but also for data sharing. I know a lot of funders require data management plans and data sharing, and so my team can help you with that. So please stay in touch. And I'll just say thank you very much for joining me this afternoon, and I can hang on if there's any questions. Thanks a lot.